Hello viewers and learners. Today we will discuss tornadoes and thunderstorms, which forms a part of MEV 002 Environmental and Occupational Hazards. I introduce myself as Dr. Sushmitha Baskar, working in the discipline of Environmental Studies at the School of Interdisciplinary and Transdisciplinary Studies, Indira Gandhi National Open University, New Delhi. Let us now understand the terms tornadoes and thunderstorms, how they affect us, how they can impact us, and what can be some of the management practices that could be done in order to save us from these disasters. The learning objectives of this module include definition of a tornado, explanation of the process of their formation, explain the impacts that are caused by them, and discuss the management of these hazards. Giving an introduction of some of the coastal hazards and disasters. If we recollect, the last few years have seen enormous damage and loss of life from the weather related disasters and hazards. A disaster or catastrophe, it can be defined as a situation or event which overwhelms the local capacity, necessitating a request to a national or international level for external assistance, an unforeseen and often sudden event that causes great damage, destruction, and also to human suffering. 9 out of every 10 of these disasters, we now understand that they are climate related. Now, high impact weather events have drastic impacts on society, on the natural ecosystems and they actually lead to great economical and personal damage. Extreme events can be both natural as well as anthropogenic origins, and they are of widespread concern because of their damaging consequences. The most damaging weather related hazard or the disasters, they include the tropical cyclones or hurricanes. The next is the thunderstorms, then we have the tornadoes, coastal storms, the tsunamis, El Nino, floods, and so on. So these are some of the most damaging weather related hazards. Let us now understand the definition of a tornado. Here in this picture you can see a vortex or spiraling kind of a structure, and which goes into its definition also. So a tornado is a rapidly rotating vortex of air protruding funnel like towards the ground from a cumulonimbus cloud. This is a definition that is given for the tornado. Most of the time these vortices remain suspended in the atmosphere, and it is only when they connect to the ground or the ocean surface that they can become destructive. The tornadoes are related to the larger vortex formation in the clouds. Thus, they often form in the convective cells such as thunderstorms or in the right forward quadrant of hurricane at larger distances, mostly more than 200 kilometers from the area of the maximum winds. It is said that the weakest hurricanes produce the most tornadoes. Tornadoes are a secondary phenomenon in which the primary process is the development of a vortex cloud, and given the large number of vortices that form in the atmosphere, the tornadoes are generally rare. But because the vortices can be generated by a myriad of processes, the tornadoes have no one mechanism of its formation. And the tornadoes may be similar to the tropical cyclones, and they are always accompanied by heavy precipitation, that is by heavy rain or rainfall. The distribution of the tornadoes. So these most frequently they occur in the North America, particularly in the central and the southeastern regions of the United States, and it's also known as the tornado alley. Then it can also occur in the southern Africa, in northwestern and southeast Europe, in western and southeastern Australia, in New Zealand, in Bangladesh, and adjacent eastern India, and also the southeastern South America. So these are normally the places where the tornadoes most frequently occur. Coming on to the formation of tornadoes. So these are narrow and funnel shaped spirals of rapidly rotating air that form in association with thunderstorms. You have seen in that figure which was given earlier how they are seen as a funnel shaped structure. Like the hurricanes and mid latitude cyclones, the tornadoes are near circular low pressure systems. However, The pressure gradient is much more intense for the tornadoes. The pressure difference across the mid-latitude cyclones are in the range of 20 to 30 millibars over hundreds of kilometers. The hurricanes may experience pressure gradients of more than 100 or even shorter distances, but large pressure differences also in the tornadoes in millibars. Okay, they can occur over the distances measured in hundreds of meters. The extreme pressure gradients of up to 0.1 or 1 millibar is possible for the tornadoes, generating the strongest natural winds on the earth with the wind velocity which can go up to 500 kilometers per hour. Now, what about the classification scale of the tornadoes? So, just like we classified the cyclones and the hurricanes with a special scale, the tornadoes also can be classified using the Fujita intensity scale. The Fujita scale, also known as the F scale or the Fujita-Pearson scale, it is a scale for rating the tornado intensity primarily on the damage the tornadoes can inflict the infrastructure, the human built structures and also the vegetation. Places the tornadoes in one of the 6 categories between F0 and F5 on that scale, and this is also according to the level of destruction which is taken as a proxy for the wind speed. So, this is a table of the Fujita scale and the F scale. You see that when it ranges between F0 and F5. So, F0 is less than 73 miles per hour, and then the range also increases between 73 to 112, 113 to 157, 158 to 206, 207 to 260 and more than 261 miles per hour. So, the scale divides the tornadoes into 3 subgroups, that is the weakest come under the F0 and the F1 level, the strongest come under F2 and F3 levels, and the most violent tornadoes can come under F4 and the F5 classification scale. Destruction that is caused due to the tornadoes. So, tornadoes are one of the most intense and destructive winds found on the earth's surface, and their destructive effects are due to the lifting force at the funnel wall, and there are sudden changes in the pressure across this boundary. The lifting force of the tornado is considerable both in terms of the weight of the objects that can be moved and shifted and destroyed, and also the volume of the material that can also be lifted from the ground. For example, the large objects weighing 200 to 300 tons, they have also been shifted tens of meters, and the houses and the train carriage that weigh 10 to 20 tons, even that also has been shifted for hundreds of meters. So, that is a destruction that can be caused by the tornadoes. How more damaging are they? They are able to suck up millions of tons of water which can be carried in the parent cloud, and they have been known to drain the water from the rivers, thus temporarily exposing the bed. The most destructive mechanism is the dip in the barometric pressure across the wall of the funnel. Air pressure in the buildings are affected by the tornado. That is the main reason for the total devastation that is caused to the buildings, and whereas the adjacent structures and the remaining remnants can appear untouched because the air pressure may be focused on one particular area in that building or that structure. Wind speeds that are high, they can cause even the automobiles to become airborne, they can rip the ordinary homes to shreds, and they can also turn the broken glass and other debris into smaller parts and material. So, that is how damaging they can be. Then the biggest threat from the tornadoes is from the flying debris and how they are being whirled about and swirled in the wind. Tornadoes also have certain shapes and sizes. So, they come in various shapes and sizes, and they are often visible in the form of a condensation funnel originating from the base of the cumulonimbus cloud with a cloud of rotating debris and dust that is beneath it. Most tornadoes, they have wind speed that is less than 110 miles per hour or 180 kilometers per hour, and they travel a few miles before dissipating. Extreme tornadoes, they can attain the wind speeds of more than 300 miles per hour, and they sometimes even stay on the ground for dozens of miles. The type of tornadoes. Various type of tornadoes including they include the multiple vortex tornado, the land spout and also the water spout. The waterspouts, they are characterized by spiraling funnel-shaped wind current connecting to a large cumulus or cumulonimbus clouds. And the thunderstorms are a common feature of the Earth's environment. There are about 1800 to 2000 storms per hour or 44,000 even more per day. So, the thunderstorms also, we have seen that they occur in the nature, and they are also a common part of these natural hazards and disasters. Now, in the tropical regions, the thunderstorms can occur daily in the wet season. So, in the wet season, you actually see them almost every day. And however, in these regions, the thunderstorm may not represent a hazard. Okay, we have seen them in the skies even when we sit on our rooftops in the terraces, because they don't intensify so much. But as the thunderstorms represent localized areas of instability, their intensity is dependent upon the factors that increase this instability. On a world scale, instability can be defined by the rate at which the base of the atmosphere is heated by incoming solar radiation, especially where evaporation at the ground and condensation in the atmosphere both occur. In this case, the saturated adiabatic lapse rate prevails. So, under all these conditions, large quantities of heat energy will be released into the atmosphere. This causes convective instability, which terminates only when the source of moisture is removed. On a localized scale, the degree of instability is also dependent upon the topography and the atmospheric conditions such as convergence. If air is forced over a hill, then this may be the impetus required to initiate convective instability. Convergence of air mass by topography or by the spatial arrangement of pressure patterns, this can also initiate an uplift. Now, the most likely occurrence of instability takes place along cold fronts, mainly the polar front, where it intrudes into the moist tropical air. What are the conditions that are required to produce a thunderstorm? So, there are three basic atmospheric conditions that are required to produce a thunderstorm. You need warm humid air that must be available in the lower atmosphere to feed the clouds and precipitation and provide energy to the storm as it develops. Then a steep vertical temperature gradient must exist in the environment, such as the rising air is warmer than the air through which it is moving. This gradient, it places colder air over the warmer moist air. Third, an updraft must force the moist air up to the colder levels of the atmosphere. So, these three conditions are required to produce a thunderstorm. Then how do they form? The thunderstorms form where the warm humid air is forced upwards to altitudes of up to 15 kilometers. The condensation occurs as the air cools, and this can release the latent heat, and it ensures that the rising air remains unstable. That means it should be warmer than the surrounding air. The thunderstorms can also occur as relatively isolated, short-lived events or as longer duration severe storms, depending upon the conditions that cause the air to rise. Then the thunderstorms form where the warm humid air is forced upwards at cold fronts or as a result of differential heating at the Earth's surface. So, these are all the ways how the thunderstorms can be formed. Then the thunderstorm formation starts as the moist condenses to form a puffy cumulus cloud, and initially the cloud will form and then it evaporates with little increase in height. Now, if the moisture supply and the updraft continue, then the relative humidity increases in the air surrounding the cloud and it grows in size instead of evaporating. The upward growth in the size of a cumulus cloud begins the cumulative stage of the thunderstorm development. In this stage, you can see the cumulus cloud becomes a cumulonimbus cloud with the growth of domes and towers that look like the head of the cauliflower, the vegetable cauliflower. This growth required a continuous release of latent heat from the water vapor condensation to warm the surrounding air, and it causes the air to rise farther. As the domes and the towers grow upward, precipitation can start by one or two of these mechanisms. First, the growth of the cloud into colder air. This can cause the water droplets to freeze into ice crystals and also snowflakes. The larger snowflakes, they will fall until they enter the air that is above freezing, and then they melt to form the raindrops. Secondly, in the warm air in the lower part of the cloud, large cloud droplets, they collide with the smaller droplets and coalesce to become the raindrops. Once the raindrops are too large to be supported by the updrafts in the cloud, then they begin to fall, creating a downdraft. Now there are also stages of development of the thunderstorm, which we already explained a little bit in the previous slides. The mature stage of the thunderstorm, we have seen the initial and how it forms. The mature stage of the thunderstorm development, this begins when the downdraft and the falling precipitation leave the base of that cloud. At this stage, the storm has both updrafts as well as the downdraft, and it continues to grow until it reaches the top of the unstable atmosphere. Commonly, this upper limit of growth is the troposphere. At this point, the updraft may continue to build the cloud outward to form a characteristic anvil shape, and during the mature stage, the storm produces heavy rain, lightning, thunder, and occasionally you can have larger chunks of ice, also known as hail. So these fall to the ground. Now in the coastal areas, these are dynamic environments that vary in their topography, climate, and also in their organisms. In these areas, continental and oceanic processes, they converge to produce landscapes that are capable of rapid change. The impacts of the hazardous coastal processes is considerable because many of the populated areas are located near the coast, and today the nation's largest cities, they lie in the coastal zone, and approximately 40% of the population lives in the coastal countries. The population density for coastal countries is 6 times greater than that of the inland countries. For example, the population in coastal countries becomes even larger during the tourist months, that is the peak vacation months. For example, in Maryland, in the Ocean City, they reported that they receive estimated 4 million visitors between the Memorial Day and the Labor Day. So that was the peak during the vacation time, that they received a large number of people and the population density was high. So the coastal problems will increase as more people live in the coastal areas where the hazards are likely to occur, and once again our activities, human activities, also continue to conflict with the natural processes. Hazards along the coast such as coastal erosion may become compounded by global warming, which is also contributing to a worldwide rise in the sea level. Now some of the most serious coastal hazards, they include the strong coastal currents, including rip currents generated in the surf zone and tidal currents in the narrow bays and the channels. Coastal erosion, which continues to produce considerable property damage that is required by human adjustment. Then we have the storm surge from the tropical and extratropical cyclones, which claim many lives and they cause enormous amounts of property damage every year. Tsunamis also are particularly hazardous to the coastal areas of the Pacific Ocean. So these are some of the serious coastal hazards that have been noticed. Finally, the El Nino and the Southern Oscillation, that is ENSO. The El Nino and Southern Oscillation is a naturally occurring phenomenon, and this involves fluctuating ocean temperatures in the central and the eastern equatorial Pacific coupled with changes in the atmosphere. They comprise 3 phases: the El Nino, La Nina and neutral. The El Nino, meaning boy child in Spanish, it was first used in the 19th century by fishermen in Peru and Ecuador to refer to the unusually warm waters that reduced their catch just before Christmas. The El Nino events often begin in the middle of the year with large scale warming of the surface water in the central and the eastern equatorial Pacific Ocean and changes in the tropical atmospheric circulation, that is the changes in the winds, in the pressure and also in the rainfall. In general, the El Nino reaches a peak during November to January and then it decays over the first half of the following year. It occurs every 2 to 7 years and can last up to even 18 months. The strong and moderate El Nino events have a warming effect on average global surface temperatures, and the opposite of the El Nino within the ENSO cycle is known as La Nina. This means little girl, opposite of that little boy, and refers to the large scale cooling of the ocean surface temperature. So there it was warming and here it is cooling in the same region in the equatorial Pacific, coupled with the reversal of the overlying atmospheric conditions. In many locations, especially in the tropics, the La Nina produces the opposite climate variations to the El Nino. During ENSO neutral phases, the atmospheric patterns are controlled by more than other climate drivers. So that was about the tornadoes, the thunderstorms, and also a little bit about the hazards that are caused by all the coastal hazards, the coastal and the weather phenomena. So in this module, dear learners, you would have understood the term about tornado, then the thunderstorms, how these are being formed, the development and the stages of the formation of both the tornadoes as well as the thunderstorms, the global distribution and where and in which are the oceans and the waters that they are occur and they are likely to be formed. And finally, we have also seen the impacts that are caused by them and the wind speeds and how even the things and the objects can be even lifted from the ground. And we have also discussed the El Nino, the La Nina and the ENSO neutral phases. This also is important for the climate variations, where we have the warm as well as the cold episodes, and so they are all the atmospheric patterns which are controlled, and sometimes even other than these other climate drivers can also control the meteorological patterns in the atmosphere and in the Earth's weather processes. Thank you.